Hello everyone, hopefully you are in a good condition right now, especially I hope that you are healthy, and we also hope that the pandemic will be over soon because we want to go back to our normal life. Okay, so for today we're gonna be talking about osmoregulation and also excretion. So before that, as we know that mostly organism body composition made of water, so the maintenance of water is so important. That's why physiological system of animals to operate in a fluid environments become a concern. And in animal that living in the water, especially the relative concentration of water in the solutes must be maintained with a fairly narrow limit. What is that with narrow limits means the gap between the concentration outside and inside the cell is not really different, because if that's too different, that's going to make a problem. For example, one of them is the cell resist, or the different concentration that make the cell could die, and also has a big problem with the metabolism if the concentration between outside and outside in it of outside and inside is so uh, different. So the mechanism to regulate the concentration and the balance between the gain and the loss of water inside a cell, especially, or inside the body, we call it as osmoregulation. Okay, that's osmoregulation. Freshwater animals. So adaptation that reduce water uptakes and conserve solutes. What it means, in a freshwater environment where the concentration of water is lower than concentration of the animal's body solutes, means that the water tend to go into the animal's body. That's why these animals try to reduce the uptake of water, and they also try to conserve the solute so they can maintain the solute inside the body. In other hands, desert and marine animals face different issue or different condition, especially because the desert, they have a very arid environment. So the animals who are which are living in that kind of place, they tend to lose water easily. And the way the organism rid of the metabolites, especially the nitrogenous metabolites and also waste, we call it as excretion. Why we talk about excretion? Because inside the water or inside the animal body, there are so many metabolism that also involve water, and some of the excess of that metabolism, we know that we have waste. That's why waste must be rid of from our body by the process called excretion. And osmoregulation is based largely on the control movement of solutes between internal fluids and external environments. Like I told you early in the beginning, that osmoregulation try or regulates the concentration between what inside the body and what outside the body. So now let's closely look what is happening with the concentration of water. So now let's see closely to the level of cells. Cells require a balance between osmotic gain and loss of water. So it means the water that can go inside and the water that can go outside, it must be in balance. Why? Because if something imbalance, the cell can go wrong and the metabolism will become the problem. And the term that mostly used in term of discussing the osmotic uh, things of the cell, we call it as osmolarity. Osmolarity is the solid concentration of a solution, and this thing determines the movement of water across a selectively permeable membranes. Do you still remember about the concept of osmosis, where the water tend to move from the high concentration of water or more water into less water? That's the basic principle of osmosis. So this is also happen with what we are going to talk right now. The condition is like this: if two solutions are isoosmotic, means the movement of water is equal in both directions. So the water that come in and the water that comes out is similar or equal. But in some other condition, if the solution differ in osmolarity, the net flow of water is from hypoosmotic to the hyperosmotic solution. So what is that? Let's see, in this jar we have two solutions, and these two solutions separate by permeable membrane, and then the two solutions consist of different concentration. The higher concentration we can call it as hyperosmotic side, and then the lower concentration is we call it as hypoosmotic side. In this case, water will move from hypoosmotic side to the hyperosmotic side. Animal, there are two types of animal, how they maintain the osmotic or how they maintain the water inside the body. The first type, we call it as osmoconformers, is the animal that mostly married, and they do not regulate the osmolarity. Why? Because the concentration inside and outside of the body are similar, so isoosmotic. So they don't need to spend a lot of energy to maintain the concentration because the concentration is similar. But some other animals, we call it as osmoregulators, they need to spend some energy to control the water uptakes and loss. Why? Because the concentration between the body and outside the body is so different. That's why they need to do the maintenance, or they need to regulate it. And this type of animal, we call it as osmoregulators. Most animals are stenohalines, means they cannot tolerate substantial change in external or osmolarity. Means some animal only can live in certain concentration that they are get used to it. But some animal that we call it as urohalines, this animal is unique because they can adjust and they can also be able to adapt into different water concentration. So for example, the salmon. Salmon is amazing in this case because they can live in fresh water, and also they can live in salty waters, and they can go either ways, like in fresh water and salty water without having no problem. Okay, so this term for salmon, we call it as euryhaline. Now let's talk about marine animals. Most marine animals, especially the invertebrate, they are osmoconformers, so they don't need to spend a lot of energy to regulate their water concentration. But some vertebrate, and mostly vertebrate, they are osmoregulators, mean they need to spend some energy to maintain the water inside the body. Marine bonifish are hypoosmotic to seawater. So what is that? Means the concentration of the solute inside the fish is lower compared to, in contrast to the environments. That's why we call it as hypoosmotic. And because of that, they tend to lose water by osmosis and gain salt by diffusion from the blood. So to do this, to make the concentration become balanced inside their body, they need to drink a lot of seawater and excreting or removing the salt intensely. Now we can see what I told you before from these pictures. The first is in saltwater fish. You can see that saltwater fish, they need to drink a lot. Why? Because the environment that they live tend to let them dehydrate. So they need to drink to get more water. But in the other hand, at the same time, they need also to remove uh, too many salt because it's gonna make the concentration is too big. So to simplify, saltwater fish, they try to maintain the concentration of water in balance to the environment by drinking a lot to make them get enough water. But during the same time, they need also to remove the extra salt from the gills. In the other hand, in freshwater fish, they they don't drink. Why? Because if they drink, they will get too much water. Why? Because the environment where they live is having higher concentration than sorry, the environment where they live is having lower concentration of the body. Mean in this case, without drinking, the fresh water will get the water from the environment. Okay, so because of that, this type of fish, they tend to excrete a lot of water to the environment. So they have excretion of large amounts of water in the dilute urine from the kidney. So they tend to remove the water as much as they can. Yeah, and they don't need to drink because they get the water indirectly. Freshwater animals, I have told you before, so this is the summary. So freshwater animals constantly take in water by osmosis from their hypoosmotic environment, and then they lose salt by diffusion and maintain water balance by excreting large amount of dilute urines. Salt loss by diffusion are replaced in food and by uptake across the gills. So that's what happened with the freshwater animals. Some animal, this is so, what should I say, extraordinary or very unique organism because some aquatic invertebrates, they can live like in tardigrade, they can dry like a seed, so that's kind of crazy things. Like when they have a big problem with dry season, so they keep their body dry and actually they're alive. So you can see from this picture that during this when they are living in the water, they're living normally, but they when they lose water, they can survive by doing dormant state and become something dry like this, like a seed. So this is very unique, and I hope I have this skill so I can survive to live longer without thinking to get enough water. So this is so amazing. One of the amazing animal that we can see how they survive in terms of the lack of water. And now let's talk about land animal. So animal living on lands. Land animals manage water budget by drinking and eating moist food and using metabolic water. So the animal that living in the land, yeah, for example, human, we got water from the drinking, right, and also eating many food that consists of water. And not only that, we some of our body also, from the metabolism, we got water from our metabolism. Desert animals get major water from uh, slightly, they are very unique because some of the body structure or the anatomical features in the desert animal is slightly a bit unique and different from us. And also they have a certain behavior that led them to do their activities during the night, or we call it as nocturnal life. Why they do it in the night? Because if they do it in the days, means that will be too hot, that will be too dry, and they tend to lose water easily. So they do the activity mostly in the night. And this type of animal, which is animal that live on the land, all of them are osmoregulators. Why? Because for example, human is the kind of animal that need to maintain or regulate the balance between the water inside and outside the body. And to do that, there's nothing free. So because we need to maintain that, means we need also to spend extra energy to do that. Let's see the two comparison between human and kangaroo rat, because we and kangaroo rat living into very different environment. We can see that uh, from the, let's see, red color at the beginning, red color here, that human only got little from metabolism. We got little water from metabolism, but kangaroo rat, they mostly got water from metabolism. Why? Because their environment is lack of water. They're living in the desert, and also from ingesting food, they just only got little. But us, in the other hand, we can get water from our drinking. So we drink a lot to maintain our body, and also from food, we get a lot also of water. That's for the intakes. And then for the water loss, we can see that mostly we spend or we loss of water from urines. That's the biggest one, and then followed by evaporation, and then the last is species. But kangaroo rat, in the other hand, they tend to lose water by evaporation, followed by urine, and then the last by feces. In some animals that living in a certain environment, for example, we can find in albatross bird. Albatross bird, mostly they fly. So this is a very big bird that fly all the time. Maybe they just go to the land just for doing reproduction. So because they fly all the time in the marine environment, so they need to drink water, which is salt water. Because of that, they need additional features in their body. So, and these additional features is certain organs that located in their heads that be able to rid of some of the salt. And this type of organ, especially in the epithelial, they have a certain mechanism how to remove the excess of salt. This is the head of the albatross, and then you can see that in the top, in not literally in the top, but in the front next to the eyes, there is what we call as nasal salt gland, and this organ is maybe simply say we can say as second kidney, because this nasal salt gland be able to remove the excess of salt into the nostril. So if we see the albatross bird, most of the time we see that they remove the water from their nose, but actually it's normal for them. Uh, Not literally that they get flu, but actually it's normal for them to remove the salt from the nostril. And the mechanism is like that because the albatross drink a lot of salt water, so inside their body there have so many salt. So the salt, let's closely look from the vessel, especially in the artery. So because there are so many salt around here, so the salt will go to the vein, and this vein interrelated to the epithelial cell, and then the salt will go this way. So start, and the salt will go, and then it will be collected, and at the end it goes to the central duct, and then it will be sent to the nostril for removal. And now we're gonna talk about excretion. So excretion is very closely related to the nitrogen waste that become the excess from the metabolism. And the type and the quantity of animal waste product may greatly affect its water balance. So the environment and how the animals get water will influence how they also rid of the waste, especially the nitrogen waste. And the nitrogen, where do they come from? They come from the protein, because most of the animal eating protein, and protein consists of a lot of nitrogens, and then from nucleic acid. That the structure of nucleic acid also consists of nitrogen. So again, the excess of this nitrogen from our metabolism, from animal metabolism, must be removed. And this waste can be converted into many types of waste product. Some of them can convert it into ammonia, some of them convert it into urea, some of them convert it into uric acid. So let's see the example. Mostly fish, they convert the nitrogen waste into what we call as ammonia, and then mammals, amphibians, shark, and then some bony fish, they convert the nitrogen waste into urea. That's why if you try to eat shark meat, uh, it's a bit fishy. It's a bit smell like urine. So you need to know how to treat the shark if you want to eat it, because if you treat it improperly, it's gonna be a bit fishy and smell like urea. And in some countries, and for example, Nati people, they put it the shark under the soil for a couple of months, if I'm not mistaken, and then after that they can consume it. And then in bird, and also insect and snail and reptiles, they convert the the nitrogen waste into uric acid. So now let's talk about ammonia. Ammonia, uh, that I told you before, mostly in the fish. So how to remove that one? They release it to the gills and also to the surface of the body. And if you are, if the animal converting the waste into ammonia, so they need lots of water to remove it. And then the second one, urea. Urea is like us, like human. Human release urea. So mostly we rid of the urea through our kidney. And but as you know, conversion of ammonia into urea, it need energy. Uh, what is that? Maybe we will not discuss it right now. So, but simply say urea must be converted from ammonia, and it requires energy. And this energy is higher compared to the energy that required to convert the waste into ammonia. Next up is uric acid. So uric acid, like I told you before, it can be found as the waste of insects, land snail, and many reptiles, and also birds. And yeah, maybe you have ever seen the poo of the bird. So that the poo of the bird is actually the mix between their digestion and also the uric acid. So how animal maintains the way they remove the waste? It's based on their evolution history, and also it's depend on their habitats. Uh, and also it has relation with how the animal live. So the energy budget of the waste, I mean the energy budget that the animal spend to convert the waste is also related with how the animal live. Yes, and this system, like I told you before, is trying to regulate the solute movement between internal and the external environments. So now let's see the process. The process is like mainly simply say we can say that the process is a filtration, and the filtration of the waste into uh, some into the ways that we can read of, because during the presentation why it's a filtrate mean, because there will be some goes, there will be some not. That's the word filtrate. And the key function of most excretory system, there are three actually. The first is filtration, and then the second is reabsorption. Reabsorption, why reabsorption? Like I told you before, because some of the things inside the blood is still important. If we talk about kidney, for example, before we got the urines, our blood will go to the kidney, right? And then some of the material will be removed, some of them will not. So some of the process to take it again, we call it as reabsorption, and then at the end, the things that is dangerous for our body, like toxin, and then some of the waste that is not important, it will be removed, and this called as extraction. And here's the basic. Uh, you know that a human has a closed circulatory system, means everything inside the blood, inside the capillary. So there must be a close relation between capillary with the filtration organ. So in this case, if we see kidney, so the capillary will go to the some of the part of the kidney that will undergo filtration, and then from there will be the absorption, and then there will be secretion, and the last will be excretion, or the removal. Now we're gonna see the type of excretory system. What are they? There are so many. So let's see number one. Number one, the very primitive, the very beginnings excretory system, we call it as protonephridium. It's actually a network of tubules that interconnected, and it has an opening. So we can see this from planaria here, or a platform. So because this animal has open circulatory system, so they have the mix the blood with the interstitial cell. So how do they filter the interstitial fluid? They will filter it to the organ called, or to the part of the cell called phlegm bulb. So if this the environment of the interstitial fluid, so it will be go this way. So let's see this. So the environment is interstitial fluid, and then it will be filtered into phlegm bulb. Let's see. So the fluid go into the phlegm bulb, and then from here it will be filtered, and from there it will be removed into the outside of the body. So the water here go this way and then remove. So this is the very beginning, or the very primitive type of excretory system. We call it as protonephridia. It's a bit more advanced, and we call it as metanephridia. It's actually almost similar, consists of tubules that collects the fluid, and we can see the metanephridia in an earthworm. So you can see again, because earthworm has closed circulatory system, so there must be a close relation between the vessel with the excretory organ. So in this case, with the metanephridia. So the waste that is exists in the vessel here will go into the metanephridia, and from there will be a filtration process, and then at the end the waste will be removed from the external opening. So the unique thing here in earthworm, every single segment consists of external opening. So if you imagine, like earthworm can be from all of the segment of the body, if human only in one particular organs, they can remove the pee from every external opening in every segment of their body. But don't imagine it, because I cannot also imagine it. But it will be so funny if we see how it's really happening. Next up, it's also more advanced than metanephridia. We have Malpighian tubules, and this Malpighian tubule we can find it in the insects and some of the arthropod, like arthropod. Insect is arthropod, like spider. Yes, spider also arthropod. So they, because the system is of the circulation is open, so the mechanism will be similar with what happened with the flatworm. So you can see flatworm, this is the environment. So the water will the interstitial fluid will go into the Malpighian tube, will be collecting here, and then at the end the waste will go into the rectum, and then together, so the feces and the urine is become one in the other hand, not in the other hand in this case. The last and the most advanced features of excretory system, we have kidney, and kidney we can find it in most advanced animal like humans, mammals. And kidney, they have a function as excretion and also osmoregulation. Why we call it excretion? Because again, it's going to remove the waste, and osmoregulation because kidney has also a function in maintaining the concentration of water inside our body. And the kidney uh, supplied with blood by renal artery, so artery that go to the kidney, and then after the blood filtered, the blood will return back to what we call as renal pain. The urines after the filtration will be collected into a duct called ureters. Maybe ureter. I believe you know about it very well. And then from ureters, all the urine will go into urinary bladder. I believe you have it. And at the end, it will go into urethra for remove it. Here's is the things that I told you before. So because again, our circulatory system is is closed. So everything must be inside the artery and also inside the vessel. So in this case, the blood that consists of many ways will go into the kidney, both right and left, and then after that there will be a process of called filtration, absorption, and everything here. And then after the filtration done, the blood will go to the renal pain this way. Okay, the blue one. Okay, so the red one goes filtration, and when it's done, go to the blue one. So in some people, they have a problem. They have problem with the kidney, so they have malfunction of the kidney. So what happened is the kidney do not work well. That's why they need a process called like hemodialysis. So means that uh, hemodialysis is the external kidney or the machinery kidney. So the blood from the body will be removed into the machine, and then from the machine it will be inserted again into the body. So yeah, keeping our body healthy, keeping our kidney healthy is very important. And by keeping doing a healthy lifestyle and also drink enough water, because if our kidney has a failure, we need to spend a lot of money to do hemodialysis, which is not good. So this is the structure of kidney. Structure of kidney consists of mostly two regions. The outer one we call it as the cortex. Cortex is the top, and then the inner one we call it as medulla. So there is cortex and medulla. So inside the kidney there are the unit that function to do the excretory process, and the unit we call it as nephron. What is nephron? Nephron is something around here, so it look like, yeah, this one is a nephron, so one single nephron. And now let's closely look what is happening with the nephron. So nephrons is like this, the structure of the nephron, and then the nephron consists of certain part. The first one is here we have glomerulus around here, and also capsula Bowman, and then followed by proximal tubule. So what is proximal? Proximal mean close, and close. So what it mean? It's close to glomerulus. And then from there we have what we call as loop of Handler. Loop of Handler this way. And from there we will have what we call is distal tubule. So what is the distal tubule mean? Distance mean far away, so it's far away from glomerulus, so that's why it's become distal. And then after the process done, we have the part what we call as renal pelvis. So this is the renal pelvis, the area for the collection of the urine, and then at the end it will go to the urinary bladder. So this is the summary of the process which about what happening. Okay, so before that, this is the process. This is glomerulus, as there is a filtration, and after it's filtrated, some of the things that still go this way will be reabsorbed, like natrium chloride, some nutrients, water, and kalium will be absorbed into the body again, and then some of the things will be inserted into the track here, like H plus and H3. So yeah, this is the summary of the process. And to know the what's really happening, we can see from this from this summary. So in the proximal tubule, there will be reabsorption of ions, water, nutrients, and some toxic will be secreted into the filtrate. So we can see that natrium chloride, nutrients, and water are reabsorbed. Okay, and then in a proximal tubule and in descending limb of loop handler. What is descending? So descending is going down. That is descending mean. So descending is the process this way. Okay, so what is happening? What is happening there is the absorption of water through channel formed by aquaporin protein. So let's see that in this case the water is reabsorbed. Okay, so in the descending one, water is reabsorbed. Now let's move to the ascending one. Ascending is climb up. So what we got, salt but not water is able to diffuse from the tubule into the interstitial fluid. Filtrate become increasingly dilute. So what happened here, the natrium chloride is get into the kidney, so the concentration here from this is become so concentrate, and from here the concentration is become a bit lower again because natrium chloride has been go out. And then in the distal tubule, what happened is the regulates K plus and natrium chloride concentration of the body fluids which contribute to pH regulation. So what happening here, there will be some K plus and also H plus inserted into this tract to maintain the pH balance. So to maintain the pH, and in this distal tubule also some natrium chlorides reabsorb again, water reabsorb again, and H, HCO3 minus also absorb again. And the last, we're gonna go to the collecting duct. Collecting duct is this one. Okay, so from this, the concentration become high again. Why? Because the let's see, because some of the natrium chloride has been removed, and then this one. So what make it become having a very high concentration is because of water is removed again here or reabsorbed. So because of less water, mean the urine that we have now is very concentrated, and this concentrated urine will go into collecting duct, and then at the end it will go to the urethra and it will go into the toilet. Okay, so that's the things that cover up about osmoregulation and also excretion. So hopefully this video help you to learn. So if you have some question, please ask me, and yeah, if you have also some question, if you don't want to ask me, you can go online or you can read the books to find many information regarding to it. But I'm happy if you want to discuss regarding to this topic. So maybe that's all for this osmoregulation and excretion topics. Thank you so much for watching and also for listening, for pay your attention to listen to my explanation, and hopefully the things that I told you will help you learn. And yeah, again, thank you so much, and we'll see you again next time. Thank you so much, and bye.